Radioactive decay process, the activity is defined as A is equal to minus dN by dt, where n is the number of radioactive nuclei at time t. So we have activity which is minus dN by dt, and this is equal to lambda into n. Now here we can see there are two radioactive sources. So for S1 we have activity 1 as lambda 1 and n1. Okay, now what is n1? N1 is the number of radioactive nuclei at time t. So n1 is equal to n1 naught e to the power minus lambda 1 into t, where what is n1 naught? It is the initial number of nuclei of S1, and t is the time after which we are seeing, and lambda 1 is the decay constant. So therefore we have for A1, okay, n1 is equal to n1 naught e to the power minus lambda 1 t, and when we multiply by lambda 1, so this is the decay constant, so therefore this becomes lambda 1 n1 naught. Okay, now at time t equal to 0, it is said that both have the same activity. Okay, so therefore we can see that A1 activity at time t is equal to 0 is equal to lambda 1 n1 naught, and for A2 the activity, for the S2 activity is going to be lambda 2 n2 naught. So this is first and this is second, and both are equal. Okay, so A1 is going to be equal to A2. Now when S1 and S2 have just completed their third and seventh half lives, so now after time t, so this t is equal to, okay, so half life is, so if you write half life is equal to ln2 by lambda, so therefore the time is 3 into ln2 by lambda 1, which is equal to 7 into ln2 by lambda 2. Okay, because it is said this is the third 3 half-lives of S1 and 7 half-lives of S2, so therefore we are writing like this. Okay, so this is again the third equation. Now it is mentioned that the ratio A1 by A2 at time t, so therefore we have for A1 activity at time t is equal to lambda 1 n1 naught e to the power minus lambda 1 into t. So what is t? T is this much, so 3 into ln2 divided by lambda 1, and for second it's going to be lambda 2 into n2 naught e to the power minus lambda 2 into 7 ln2 divided by lambda 2. Now we have to find out this ratio. Okay, so lambda 1 and lambda 1 is gone, lambda 2 and lambda 2 is also gone, and lambda 1 n1 naught is equal to lambda 2 n2 naught, as we had seen this, since A1 is equal to A2, so therefore they both also cancel each other. So therefore what we are left with is E minus ln2, okay, to the power 3 divided by e to the power minus ln2 to the power 7, which is e to the power ln2 to the power 7 divided by e to the power ln2 cube. Now e to the power ln2 7, if we keep it as x, so if we take ln on both the sides, ln x is equal to ln2 to the power 7 into ln of e. Now ln of e is going to be 1, so therefore x is going to be 2 to the power 7, so this becomes 2 to the power 7 and this becomes 2 to the power 3, so therefore it's 2 to the power 4, which is 16. So therefore the answer is going to be 16.